The idea that gut microbes can influence human behavior may sound far-fetched, but mounting evidence suggests it's not only plausible, it's happening all the time. Inside the human body, trillions of microorganisms engage in a constant, invisible dialogue with the brain, subtly shaping decisions, moods, and cravings. While we often think of behavior as a product of willpower or personality, science is beginning to show that the microbiome plays a silent yet powerful role in modulating the way we feel, eat, and react. This influence is especially notable in behaviors involving impulse control, emotional regulation, and food-related decision-making. Gut bacteria are capable of producing and regulating neuroactive compounds like serotonin, dopamine, GABA, and short-chain fatty acids, each with known effects on brain function. More than 90% of the body's serotonin is made in the gut, not the brain. Certain bacterial strains can influence how much is produced and how effectively it interacts with receptors. These microbial signals don't need to cross the blood-brain barrier to have an effect. They can work through the vagus nerve, immune modulation, and the gut's own neural network to adjust the brain's sensitivity to stress, reward, and satisfaction. The result is that some people may feel chronically anxious, impulsive, or fatigued not just due to life circumstances, but because their microbiome is sending altered chemical messages to the brain. Animal research has made this influence even clearer. Germ-free mice, those raised in sterile environments without any gut bacteria, display abnormal behavior, including increased anxiety, hyperactivity, and impaired social interaction. When specific microbial strains are introduced, some of these behaviors normalize. In one landmark study, a strain of Lactobacillus rhamnosus was shown to reduce anxiety-like behavior and change GABA receptor expression in mice brains, but only when the vagus nerve was intact. This points to a direct gut-to-brain line of communication that bypasses hormonal systems entirely. Moreover, rodents with altered gut flora often eat differently, preferring high-fat or high-sugar foods and exhibiting binge-like behaviors under stress, suggesting that microbes may influence not only mood but also reward-based behavior. In humans, while the evidence is more correlative than causal, the patterns are compelling. People with depression, anxiety, or attention disorders often have less diverse microbiomes and show elevated levels of inflammation, suggesting the gut-brain axis is disrupted. Interventional studies using probiotics have reported modest but meaningful improvements in mood, impulse control, and food cravings. Though not all studies are conclusive, a consistent pattern emerges. A healthier, more diverse gut microbiome tends to be associated with greater emotional resilience, better decision-making, and more stable eating behavior. This behavioral modulation seems to work through multiple, overlapping systems. One is through the immune system. Dysbiosis in the gut can lead to increased intestinal permeability, allowing bacterial components like lipopolysaccharide, LPS, into circulation. This triggers a state of low-grade systemic inflammation that affects brain function, particularly in regions like the prefrontal cortex that govern executive control and long-term decision-making. Inflammation in these areas has been linked to greater impulsivity, emotional reactivity, and reduced ability to delay gratification, all behaviors that characterize many modern health challenges, including overeating, substance use, and anxiety disorders. Another layer involves the brain's reward systems. Microbial metabolites influence how dopamine is processed in the brain, changing how strongly we experience motivation or pleasure in response to food, social interaction, or stress. Some researchers have even proposed that certain microbes may hijack this system, increasing our craving for specific foods that help them thrive. For instance, bacteria that feed on sugar may increase the production of signals that encourage the host to consume more simple carbohydrates. Though these theories remain under investigation, they're supported by a basic evolutionary logic. Microbes that improve their survival chances by shaping host behavior would have had a selective advantage over time. What emerges from this growing body of research is a picture of the microbiome not as a passive passenger, but as an active player in behavioral health. It influences not only digestion and immunity, but also how we feel, what we crave, and how well we regulate ourselves under pressure. Behavior, in this context, is not solely the product of conscious thought or environment. It is also the outcome of a complex neurochemical dialogue that begins deep in the gut. While the idea of microbial control may sound unsettling, it also holds promise. If microbes can push behavior in harmful directions under certain conditions, they can also be guided through diet, lifestyle, or therapeutic interventions toward patterns that promote balance, calm, and self-control. Rather than undermining the concept of free will, this perspective expands it. By acknowledging the role of the microbiome, we gain new tools to understand and influence the biological roots of behavior. This opens the door to future strategies that don't rely solely on willpower or pharmaceuticals, but instead use microbial support to improve how we feel and function. The microbiome may not dictate our behavior, but it certainly helps to shape the landscape in which those behaviors unfold. And by listening to what our microbes are saying, we may learn more about ourselves than we ever thought possible.